The last normal thing Alex did was flag the object as debris, designation KBO2274, a Kuiper Belt object 41 astronomical units out, picked up by the survey telescope during a routine sweep, slow rotation, weak reflectivity, the kind of object the catalogue absorbed 100 of every month without anyone looking twice. Alex tagged it, moved the cursor to the next frame, and reached for the coffee that had gone lukewarm an hour ago. Ilara wasn't glamorous. It was a survey platform, not a flagship. 4 modules bolted together around a shared reactor, built to do one job for 10 years. Point instruments at everything drifting through the outer solar system and catalogue it before moving on. Most nights, that job looked like paperwork with better scenery. Rocks, mostly. Ice, mostly. The occasional interesting spectral line that turned out, on the second look, to be nothing. Alex had been doing this work for 6 years, and in 6 years, nothing had ever looked back. Then the spectrometer read it wrong. Not wrong the way instruments are usually wrong, a bad pixel, a cosmic ray hit, a calibration drift. Wrong the way a number is wrong when it shouldn't exist at all. The albedo curve had a step in it, a hard edge, precisely repeating every 6.2 hours, exactly matching the rotation period. Rocks don't have hard edges. Rocks don't repeat. Alex sat back down. That was 0314, station time, aboard the deep survey platform Ilara, 400 million kilometers from a planet where, at that exact moment, almost 8 billion people were asleep, awake, arguing, falling in love, completely unaware that the loneliest number in their universe had just, for one person on one night, stopped feeling infinite. Here is what you need to know before anything else. Right now, as you take this in, you are living inside the only confirmed example, anywhere, of a mind that knows it exists. Not the rarest example humanity has found, the only one. Every telescope ever built, every radio dish, every probe, every survey of every patch of sky for 70 straight years has returned exactly one answer to the question of who else might be out there. Silence. There's a story behind why that silence bothers physicists so much, and it starts, unglamorously, with a lunch. Los Alamos National Laboratory, 1950. A handful of physicists walking to the cafeteria, joking about a newspaper cartoon that blamed the disappearance of garbage cans in New York on aliens. Everybody laughed. Then Enrico Fermi, Nobel laureate, one of the architects of the atomic bomb, a man who did not deal in whimsy, stopped mid-conversation and asked 2 words that nobody in the group could answer. Where is everybody? He wasn't being poetic, he was doing arithmetic, and he'd apparently been doing it in his head the whole walk over. The galaxy holds somewhere between 200 and 400 billion stars. It is over 13 billion years old. Even a civilization crawling between stars at a tiny fraction of light speed, a technology that looks almost achievable from where humanity stands right now, could cross the entire galaxy in a few million years. Geologically, that's nothing. It's less time than it took dinosaurs to rise and vanish. So if even one civilization anywhere at any point across 13 billion years had reached that level and started expanding, its ships should already be here. Its beacons should already be humming in every direction. Its ruins should be visible in 100 different telescopes. They aren't. Not one signal, not one structure, not one confirmed artifact anywhere, ever. Fermi himself never wrote the paradox down in the form people quote today. He just asked the question at lunch and let it sit there, unfinished, the way good questions sometimes get left. It took another 25 years for an astronomer named Michael Hart to turn it into something harder to ignore. In 1975, Hart argued bluntly that the absence of any extraterrestrial presence on Earth right now was itself strong evidence that advanced civilizations simply don't exist, because if they did, given enough time, they would already be here. Given a galaxy 13 billion years old, enough time was the one resource that should never have been in short supply. Alex knew the paradox the way most planetary scientists do, as something you joked about at conferences, a thought experiment that never actually intruded on a Tuesday night shift. Not as a hard edge on a screen at 3 a.m., repeating exactly where nothing should repeat. She rescheduled 6 hours of the telescope's time, alone, without waking anyone, telling herself this was still, almost certainly, nothing. It was not nothing. By the second night, high-resolution imaging showed a surface with a crater distribution that didn't match anything natural. Too few small impacts, too many mid-sized ones, spaced with a regularity that impact physics simply does not produce on its own. By the third night, radar returned an internal density profile inconsistent with either rock or ice, a solid metallic core centered with a precision accretion never achieves by accident. By the fourth night, Alex woke the rest of the crew. There were 4 of them on Ilara. Alex, a planetary scientist, Yusuf, the mission engineer, Priya, who ran the radio and laser communications suite, and Thomas, the commander, 30 years in orbit, who had by his own count been woken for an emergency 11 times before this one, none of which had turned out to be nothing. He looked at the data for a long time before he said anything. "You're telling me a rock has a heartbeat?" "I'm telling you a rock has a rotation period that matches a repeating internal structure that matches a surface pattern that doesn't occur in nature," Alex said. "I'm not telling you what it is. I don't know what it is." "Guess anyway." She didn't answer right away. Outside the window, the object was a faint smear of reflected sunlight, cold enough that its surface sat within a few degrees of absolute zero, old enough, and this was the number that had kept Alex from sleeping, that the crater counting models, run 3 separate times with 3 separate assumptions, kept returning the same range. 480 million years, plus or minus 60. Before there were fish with jaws. Before there was anything on land bigger than a spore. 480 million years ago, the most complex organism on Earth was something like a trilobite, working blindly across a seafloor under a sky that had no witnesses. Something had been built and launched, and had been drifting in the dark since before evolution had gotten around to inventing eyes. Before this goes further, it's worth understanding exactly how improbable that sentence is, because the improbability is the whole story. In the year 2000, 2 scientists, Peter Ward and Donald Brownlee, published a case that most people who talk about aliens have never fully reckoned with. They called it the rare Earth hypothesis, and their argument wasn't that life itself is rare. Simple life, they conceded, might be common. Anywhere there's water and chemistry and time, something might start stirring. Their argument was that complex technological life requires a list of conditions so long and so specific that satisfying all of them simultaneously might be closer to a miracle than a statistic. A large moon formed from a single catastrophic, precisely angled collision early in a planet's history, stabilizing axial tilt for billions of years. Plate tectonics, recycling carbon and regulating climate over geological time. Without it, a planet becomes either a furnace or an ice ball, the way Venus did. A galactic address that isn't too close to the crowded, radiation-soaked center, and isn't too far out in the metal-poor edges, sitting instead in a narrow galactic habitable zone. An almost perfectly circular orbit around that galactic center, spending most of its time between the spiral arms where supernovae are rare. A precise ratio of ocean to land. An atmosphere balanced across oxygen, nitrogen and greenhouse gases, tightly enough to stay life-supporting for billions of consecutive years without tipping either direction. A gas giant positioned far enough out to sweep up comets and asteroids before they reach the inner system, without being so influential that it destabilizes everything closer to the star. A stable, long-lived star in the first place, not too massive to burn out in a few 100 million years, not so small and dim that any habitable zone sits close enough to trigger the tidal locking that kills a day-night cycle entirely. Ward and Brownlee counted over 100 separate conditions like this. Multiply the probabilities together, and the number that comes out isn't small. It's close enough to zero that, statistically, Earth itself starts to look less like an example and more like an outlier. Which means whatever built the object floating outside Alara's window hadn't just evolved. It had won a lottery with 100 separate tickets, all of which had to come up at once, on some other world entirely. And then it had gone further than we ever have. It had built something meant to last across geological time. Alex thought about this on the fifth night, running the numbers again, feeling something that wasn't quite excitement and wasn't quite dread, sitting somewhere in the narrow space between them. She had spent 6 years cataloguing rocks precisely because she had made peace, a long time ago, with the idea that nothing out here was ever going to look back. It was easier that way. A universe that couldn't answer was a universe you could study without it costing you anything. Now the numbers on her screen were quietly taking that piece apart, 1 decimal place at a time. The team spent the next 11 days doing the only thing scientists know how to do with a mystery. They took it apart, carefully, 1 measurement at a time. Yusuf ran a low-power radar mapping pass and found internal chambers. 3 of them, symmetrical, arranged around the metallic core like the rooms of a building nobody had entered in longer than most species survive. Priya swept every frequency the communications suite could reach and broadcast patiently on a repeating loop the only thing that seemed to make sense to send. Prime numbers. 1, 2, 3, 5, 7. The oldest assumption in the search for extraterrestrial intelligence, that any mathematical mind, however alien, would recognize a sequence that nature doesn't produce on its own. Nothing answered. Thomas ran the trajectory backward, the way you'd trace a bullet to a gun, correcting for 480 million years of the sun's own drift through the galaxy and every neighboring star's motion around it. An approximation, he kept saying, with error bars the size of a small galaxy. It pointed, roughly, toward a region matching the current position of a star that catalogues showed had already exhausted its hydrogen and quietly become a white dwarf sometime in the last 100 million years. So the star's dead, Priya said on the 11th night, once the pieces had accumulated enough to say something out loud. The star that sent it might not be the star it originally came from, Alex said. It could have been relayed, refueled somewhere along the route. We don't know how long the journey actually took or how much of that 500 million years was travel versus waiting. But if it did come from there, Priya said, and that star's core stopped fusing that long ago, nobody finished the sentence. Everyone already knew how it ended. Here's a fact worth sitting with, one that has nothing to do with this specific object and everything to do with why finding it feels the way it does. For any 2 civilizations in a galaxy this large and this old to actually meet, not just exist somewhere within the same 13 billion year span, but overlap closely enough in both time and space that a signal sent by one could reach the other while both are still capable of sending and receiving anything at all, requires something close to a coincidence stacked on top of another coincidence. Space is the first problem. The Milky Way is roughly 100,000 light-years across. A radio signal crossing even a modest fraction of that distance takes centuries. A physical probe crossing it, at any speed physics currently considers plausible, takes tens of thousands of years at minimum, more likely millions. Time is the second problem, and it's the one people forget. A civilization's technological window, the span during which it can build something like a telescope or launch something like a probe, and also still exists to receive an answer, might last centuries. It might last a few 100 years before it destroys itself, outgrows the need for the technology, or transforms into something no instrument can detect. Against a galactic history of 13 billion years, a window like that isn't a long note held across time. It's a spark, one frame in a reel with billions of frames. Two sparks occurring at different points across a 100,000 light-year disk over 13 billion years, aligning closely enough in both space and time to notice each other. The geometry of that coincidence is the real reason the sky is quiet. Not because the galaxy is empty, because it is enormous and old, and every civilization that has ever existed inside it has been, from the perspective of galactic time, a candle lit for a moment in a room the size of a continent, in a building that has stood for 10,000 years. There's a way to picture this that makes the scale easier to hold on to. Imagine a galaxy as a city of millions, except every resident lives for exactly one day, born at dawn, gone by nightfall. If, on any given day, only a handful of people happen to be alive at the same time, the odds that any two of them cross paths on the street are close to nothing. The city would look empty to anyone walking through it, even though millions of people had lived and died inside it. Not because the city was uninhabited, because life there was too brief and too scattered across time for its residents to ever meaningfully overlap. That's the galaxy Alex was looking at. Not empty, unsynchronized. Most candles never see another candle, not because there's only one candle, because the room is too big and the candles don't stay lit long enough to find each other. Whoever sent the thing floating outside Alara's window had understood this problem well enough to try solving it. They hadn't shouted and hoped. They had built something durable enough to wait past their own extinction if it had to, aimed it at a star with planets that might, someday, produce something worth waking up for, and let go. There's a number that's worth knowing here, because it's the number every conversation about this eventually collapses into. In 1961, an astronomer named Frank Drake organized the first serious scientific conference on the search for extraterrestrial intelligence, and to prepare for it, he sketched a simple equation on a chalkboard. 7 factors, multiplied together, meant to estimate how many communicating civilizations might exist in the galaxy right now. The rate stars form, the fraction with planets, the number of those planets sitting in a habitable zone, the fraction where life actually starts, the fraction of that life which becomes intelligent, the fraction of intelligent life that develops detectable technology, and last, the average lifetime of a technological civilization once it exists. Drake plugged in his own best guesses and got an answer of 10. 10 civilizations right now capable of talking to us. The problem, the one that has haunted the equation for 60 years, is that the first 2 terms are the only ones modern astronomy has actually measured with any confidence. Stars with planets turned out to be nearly universal. Everything after that, starting with the odds that life begins at all, remains a guess dressed up as a variable. And the very last term, the average lifespan of a technological civilization, turns out to matter more than all the others combined. Multiply everything else by a large, hopeful number, and it still collapses to almost nothing if civilizations only survive a few centuries once they reach this stage. Alex thought about that last term more than any other, sitting with the data from KBO 2274. Because whatever built it hadn't just survived a few centuries, it had survived long enough to build something meant to outlast it by 500 million years. And it still hadn't been enough. In 1960, a radio astronomer named Ronald Bracewell published an idea that most of his colleagues treated as a curiosity rather than a serious proposal. He'd noticed a flaw in how everyone was thinking about interstellar contact. The standard assumption, the one behind every SETI radio search since, was that 2 civilizations would need to be broadcasting and listening at the same time, in the same direction, on the same frequency, for a signal to ever be caught. Given how brief a civilization's broadcasting era might be against the age of a galaxy, Bracewell pointed out, the odds of 2 such windows overlapping were vanishingly small. His alternative was stranger and, in its way, more patient. Instead of shouting into the dark and hoping someone happens to be listening at the right moment, a civilization could build something that didn't need to shout at all. A probe sent once, aimed at a promising star system that arrives and then simply waits, dormant, powered down to almost nothing for as long as it takes. Thousands of years, millions if necessary. Watching for a signal, a light, a radio leak, any evidence that something on the target world had finally woken up enough to notice it was being watched. Only then would it activate. A message in a bottle, except the bottle can wait for geological time, and the ocean it's floating on is a solar system. There was a second reason Bracewell's idea made sense, one that had nothing to do with patience and everything to do with energy. A continuous radio broadcast, powerful enough to be heard across dozens or hundreds of light years, requires an enormous and sustained power output, maintained for as long as anyone hopes to be heard. Decades, centuries, indefinitely, with no guarantee anyone is ever listening. A dormant probe, by contrast, spends almost nothing while it waits. It only needs to wake up once, briefly, if it ever detects something worth waking up for. For a civilization thinking in terms of resources instead of hope, the probe was, on paper, the cheaper bet. There's a companion idea developed decades later by the Polish writer and scientist Stanislaw Lem that fits alongside Bracewell's almost too neatly. Lem argued that every civilization passes through a narrow contact window, a brief historical period during which it actively leaks radio signals into space, before either destroying itself or migrating to communication technologies that don't broadcast outward at all. For a species like ours, Lem estimated that window might last 300 to 500 years before quieter, more efficient methods replace it entirely. If every civilization's radio-loud phase is that short, and the galaxy is that old, then two such windows lining up, close enough in distance, aimed in the right direction, on overlapping frequencies, becomes close to a statistical impossibility. Civilizations don't fail to find each other because they're absent. They fail because their moments of visibility are too brief and too far apart in time to ever coincide. Bracewell's answer to that problem was patience made physical. Don't wait for two brief windows to align. Build something that can outlast its own civilization's window entirely and let it do the waiting instead. Whoever built KBO 2274 had, as far as Alara's crew could tell, done exactly that. And then, at some point in the last several 100 million years, simply stopped being capable of maintaining it. Not through violence, not through any dramatic ending, through the ordinary, unglamorous fact that stars run out of fuel, civilizations run out of centuries, and 500 million years is a very long time to keep anything running, even something built to wait. On the 14th night, Alex sat alone in the observation module, the way she'd started doing most nights since this began, and looked at the smear of reflected light where KBO 2274 sat. Thomas found her there. "You've been staring at a rock for 2 weeks, he said, not unkindly. "It's not a rock." "I know what it's not. I'm asking what you think it is." Alex thought about how to answer that honestly. "I think it's a letter," she said finally. "Written by someone who understood they'd probably be dead before anyone read it. Sent anyway." Thomas sat down next to her. "You think they're gone, the senders?" "I think the star their trajectory points to stopped being a star that could support anything 500 million years before we existed. I think whoever built this thing sent it out knowing they'd never live to see a reply, and did it anyway." "That's either the saddest thing I've ever heard," Thomas said, "or the least sad." "I haven't decided which," Alex said. They sat there for a while without talking, the way people do when a conversation has reached the edge of what words are actually for. Outside, KBO 2274 kept rotating on its 6.2-hour cycle, the way it had for 480 million years, indifferent to whether anyone was watching. On the 18th day, back on Earth, the wider scientific community got word, and the debate that followed inside Alara's small crew turned out to be a miniature version of one that had been running for 70 years. Yusuf, the engineer, was the first to say what everyone had been circling. "Maybe it's not that they died naturally," he said during dinner in the flat tone of someone thinking out loud. "Maybe something happened to them. Maybe something always happens." He was describing what scientists call the Great Filter, the idea, first formalized by economist Robin Hanson in 1996, that somewhere along the long road from simple chemistry to a galaxy-spanning civilization, there exists at least one barrier so difficult that almost nothing gets past it. The unsettling part isn't that the filter exists, it's that nobody knows whether humanity has already passed it or whether it's still ahead. If the filter is behind us, if the leap from non-life to life, or from simple cells to complex ones, or from complexity to intelligence is the improbable part, then humanity is already rare and safe, and the silence of the galaxy is simply the sound of an empty room we're lucky to be standing in. But if the filter is ahead of us, the silence means something else entirely. It means every civilization that ever reached roughly humanity's current stage, nuclear weapons, biotechnology, planet-scale industry, artificial intelligence, eventually ran into something it couldn't survive. War, runaway technology, ecological collapse. Something built by minds smart enough to create it and not quite wise enough to control it. If that's true, Yusuf said, then whatever built this thing got further than we have. They built something that survives 500 million years, and they still didn't make it. Priya disagreed, quietly, over the same dinner. Or they made a choice, she said. Maybe nobody has to die to explain a silent galaxy. Maybe intelligent species figure out, eventually, that reaching out is the dangerous part. This was the argument known as the Dark Forest, popularized by the novelist Liu Cixin, but taken seriously by a number of physicists as a genuine possible answer to Fermi's question. Its logic runs like this. In a universe where distances are vast, communication is slow, and no civilization can ever be certain whether another is friendly or not, the only rational move, from the perspective of pure survival, is silence. You cannot verify intentions across light years and centuries. You cannot risk revealing your location to something that might, one day, decide you're a threat worth eliminating before you become one. So everyone hides. Every civilization capable of understanding the risk goes quiet, and the ones that don't understand it are the ones that get removed early by whoever's already out there listening. The logic laid out step by step is uncomfortably hard to break. You cannot be certain another civilization is peaceful, even if it says so. It could be lying or mistaken, or simply capable of changing its mind later, across generations you'll never observe. You cannot wait to find out, because by the time you're sure, the technology gap between you may have already flipped in their favor. And you cannot risk being wrong even once, because the cost of guessing wrong isn't a setback, it's extinction. So the only strategy that survives contact with that logic, again and again, across every civilization smart enough to reason it through, is silence. Or, if you're ever detected first, elimination before you can be threatened yourself. Stephen Hawking made a version of this same argument publicly more than once, comparing a hypothetical human encounter with a far more advanced civilization to the encounter between the indigenous peoples of the Americas and Columbus's ships, an event that had, for one side, ended in catastrophe. Reaching out first, in his view, wasn't curiosity, it was risk, aimed at ourselves. If that's true, Thomas said, then sending anything at all, a probe, a signal, anything, is the single worst thing a civilization can do. Except this one did it anyway, Alex said. Whoever built this took the risk. They reached out despite knowing every reason not to. There was a third possibility, and Alex was the one who raised it on the 20th night, mostly because she wanted to believe it. The zoo hypothesis, first proposed by astronomer John Ball in 1973, suggests that advanced civilizations are out there, aware of us, and simply choose not to interfere, the way a nature preserve keeps its distance from the animals inside it, waiting for a species to reach some threshold of maturity before contact is made. It's the most comforting of the explanations, and also, most researchers agree, the least likely to survive scrutiny. It requires near universal agreement across thousands of unrelated civilizations, evolved under entirely different conditions, all choosing the exact same ethical restraint. It only takes one exception, one culture, anywhere, that decides to make contact regardless, for the silence to break. And after 70 years of listening, it never has. Yusuf pushed back on it harder than either of the other two ideas. It doesn't just require one civilization to be restrained, he said. It requires every single one of them to agree on the same rule forever, with no coordination possible across light years. Thousands of unrelated species evolved under completely different pressures, all landing on the exact same ethics about non-interference. On Earth, we can't even get every country to agree on anything for more than a decade. Why would the whole galaxy manage unanimous restraint for 1 billion years? Nobody had a good answer for that either. Maybe it's simpler than all of that, Thomas said eventually. Maybe nobody's filtering anybody. Maybe nobody's hiding. Maybe it's just what Alex keeps saying, distance and time. The room is too big and everybody's candle burns out too fast. Nobody had an answer that made all three ideas go away. That was, Alex thought later, the most honest place the conversation could have ended. Carl Sagan used to point at that last term in Drake's equation, the average lifetime of a technological civilization, and call it a warning rather than a variable. All the other factors, he argued, could be as generous as anyone liked. Stars, planets, habitable zones, even the odds of intelligence itself. None of it mattered if civilizations reliably destroyed themselves within a few centuries of gaining the power to do so. In that case, the galaxy could be extraordinarily fertile and still look, at any given moment, almost completely empty, because almost nobody survives long enough to be counted. Alex found that thought harder to sit with than any of the others, because KB 02274 didn't fit neatly into it. Whoever built the probe hadn't failed within a few centuries. They'd built something meant to function for geological time, something that implied long-term thinking on a scale humanity had never once managed collectively. And they still hadn't made it far enough to answer. If a civilization capable of that kind of patience could still run out of time, the filter wasn't only a young civilization's problem. It didn't only wait for the reckless. Sometimes, maybe, it simply waited for everyone. By the 20th day, the news had already left Elara. It had to. Protocol required reporting any anomaly of this magnitude to Mission Control within 72 hours. And Mission Control, in turn, had no way to keep something like this contained for long. Within a week, the story was everywhere. An artificial object, 500 million years old, found drifting at the edge of the solar system. The reactions split, roughly, the way every serious study of first contact scenarios had always predicted it would. Shock came first, the specific, disorienting shock of an entire species discovering, all at once, that it was not the only mind that had ever looked up and wondered. Then came the questions, thousands of them, arriving faster than anyone could answer. Who built it? How advanced were they? Were they still out there somewhere? Should humanity try to answer? And if so, who had the right to speak for an entire planet? Panic followed close behind, in the usual places. Conspiracy theories, claims that governments had known for decades, a spike in anxious searches for what an alien visitation might mean for someone's particular religious tradition. And underneath all of it, quieter, harder to interview anyone about, there was something that looked a great deal like hope. Not that the senders would return, almost everyone understood within days that they wouldn't, but hope all the same in simply knowing that somewhere, once, another mind had stood where humanity now stood, asking the same question, refusing to let the silence be the last word. On the 22nd day, the analysis team on Earth confirmed what Elara's crew had already started to suspect on their own. The internal chambers were empty. Whatever mechanism had once been meant to activate on detecting a signal had failed or degraded, or simply run out of whatever it needed to run on, sometime in the last several 100 million years. There was no waking it up. There had never been anyone left, in any sense that mattered, to answer Priya's prime numbers, patiently repeating into a silence that had already been permanent for longer than most species get to exist at all. It wasn't dead the way something is dead when it stops. It was dead the way a letter is dead once everyone who might have opened it has also died, and their children, and their children's children, on down a line that eventually runs out of people who would even recognize the handwriting. Alex wrote the final entry in the mission log 2 nights before Elara's observation window closed and the platform moved on to its next assigned target, the way it always would, the way the mission plan required, indifferent to what had just been found floating in the dark. The entry read, "We are not the first minds to ask if we are alone. We may not even be the first minds to build something and send it outward, hoping, against every reasonable calculation, for an answer. What we found was not proof that we are alone. It was proof that someone else, once, was not, that they thought hard enough about loneliness to try to solve it, and built something meant to outlast their own certainty of failure. It didn't work. Not because they were wrong to try, because the two things that needed to line up, a sender still capable of listening and a receiver ready to answer, never once, across 480 million years, occupied the same moment. We don't know if we're early or late. We only know, now, that we are not alone in having asked. There's a parallel worth naming here, one that keeps surfacing whenever a story like this gets told carefully enough. 230 million years ago, a different Alex, the one used before to think through impossible situations, stood on the supercontinent Pangaea in a world still assembling itself into something that could someday support a species that asks questions like this one. That Alex couldn't survive there because the planet wasn't finished yet. More recently, another Alex stood at a polar station and watched a planet that had impossibly stopped turning and understood, standing in the wreckage of everything rotation had quietly provided, that the ground under a civilization is never as permanent as it feels. This Alex found something different from either of those. Not a world unfinished, and not a world undone. A message sent by someone who had already finished long before we began. A civilization whose entire technological era, whatever it looked like, however long it lasted, had opened and closed the way ours will, the way every one of them apparently does, inside a galaxy too large and too old to notice most of what happens inside it. The candle gets lit. It burns for as long as it burns. Somewhere in the room it goes looking for another candle. Most of the time, by the time it finds one, it's already gone out. 3 Alexes, 3 planets, 3 different ways for a mind to discover how small its moment is. One arriving too early, one watching the ground itself betray 4.5 billion years of habit. One finding proof that somewhere else, at some other early or late moment, the same discovery had already been made, and answered with an act of almost unreasonable hope. One question before we go. Somewhere out there, right now, unseen by any instrument humanity has built, there may be another mind looking at its own sky, doing its own arithmetic, wondering the same thing you're wondering as you read this. Not whether the universe is empty, whether it simply never lines up, whether every civilization that has ever existed has been a light turned on for a few centuries in a hallway 13 billion years long, always missing every other light by margins too vast to close. If you knew with certainty that any message you sent outward would only be read after everyone who sent it was gone, would you still send it? It's worth sitting with how strange that question actually is, because it isn't really about aliens at all. Every letter written to a future generation, every tree planted by someone who'll never sit in its shade, every warning left for descendants about a mistake being made right now, all of it depends on the same quiet act of faith the builders of KBO 2274 made 500 million years ago, that someone, someday, will be there to receive it, even if you never get to find out. Write it in the comments. KBO 2274 is still out there, cold, dark, silent, its chambers empty, its rotation steady, carrying a 500 million year old letter that nobody is left to read and nobody has yet learned to answer. It's still doing the only thing it was ever built to do. It's still waiting.